Hello and Assalamualaikum. So this is our group presentation for the Inferential Stat project. So we will be analyzing daily rainfall data in Malaysia and identifying the best fitted statistical model. So we are from group 2 called No Cap Just Stats, and today we are going to walk you through our finding. So this is our group members. Okay, we will start with the research background first. So basically, rainfall plays a key role in Malaysia's environment, like supporting the agriculture, water supply, and the ecosystems. So Malaysia's climate is shaped by two major monsoon seasons, which is northeast and the southeast monsoon, which affect the rainfall timing and intensity across the region. So there are three main types of rainfall, which is frontal, orographic, and convective, which help to explain the differences in rainfall pattern, and air pressure system also influence how rain is formed. Then, analyzing rainfall is important to detect the seasonal changes, understanding the extreme events, and support better planning for disaster, agriculture, and water management. So in this study, we analyze daily rainfall data from 2010 to 2020 using 5 selected stations, and 5 statistical distribution were used to model the data. So parameters were estimated using MLE, and the model fit was tested using KS test and AIC.
Next, rainfall analysis is crucial for hydrology, climatology, and environmental planning, especially in tropical regions like Malaysia. It helps with water resource management, agriculture, and flood risk assessment. Studies show that no single statistical distribution fits all rainfall conditions. Common models include log normal, gamma, Weibull, exponential, and Gumbel. Each has different strengths, which is gamma and log normal are stable across seasons, while Weibull and Gumbel were best for extreme events. ML is widely used to estimate model parameters due to its efficiency and consistency. Goodness of fit tests like KS and AIC help evaluate how well this model fit the data. The combination of MLE with AIC or KS has become the standard method for rainfall modeling in tropical climates like Malaysia's. The objectives of this study are to produce a clean and filtered dataset of daily rainfall on wet days from 2010 to 2020 by using Microsoft Excel. Next, to estimate the parameters of selected statistical distribution by using the MLE method. Moreover, to evaluate the goodness of fit of the selected distribution and identify the best fitting distribution for daily rainfall data at each station using the KS and AIC in R software. Lastly, to compare the best fitting distribution across 5 meteorological stations in Malaysia and relate the result to geographical location and monsoon influence. The rainfall data used in this study was obtained from the Malaysian Meteorological Department, covering 11 years from 2010 to 2020. Only wet days with rainfall of at least 1 mm per day were included. A total of 5 stations were selected across Malaysia based on geographical location, monsoon influence, topography, and data completeness. Each station shows unique rainfall behavior. For example, Kota Baru experienced strong northeast monsoon influence and high seasonal rainfall, while Kuching has the highest rainfall frequency due to convective and monsoon activity. These 5 stations provide a diverse and representative dataset for study both seasonal and extreme rainfall patterns across Malaysia.
To estimate the values of parameter, maximum likelihood estimation is employed due to the large sample size from the rainfall data for each selected station, given 5 different statistical distribution presented here. The rainfall dataset for the 5 selected stations are used during the computation of MLE in R programming. The results for all distribution in each station are tabulated in the table presented here. To compute the MLE in R programming, 4 important aspects must be considered: packages to call for functions or command, clean and filtered rainfall data, functions or command for computation, and parameter estimation output to store the values of estimators. In the next slide, the presentation will demonstrate the R programming to obtain the MLEs for all the given distribution function across the selected stations.
The required packages is already installed and loaded in the R programming. Next is to import the 5 selected station data by using the function read.csv. In the environment panel, we can see all the 5 stations has already been imported. We will use Allostar in this demonstration to obtain the MLE. In most distribution, the function used is fitlist. I'm using GD with shift 0 using the function. We will run all the distribution in Allostar. In the environment panel, we can see the name of the data here, MLE AXP, stands for exponential distribution in Allostar. We click here and will appear the values of parameter data, as well as for gamma distribution, Campbell distribution, log normal, and Weibull distribution.
In this part, our main goal is to find the best distribution to model rainfall using 5 distribution, which is log normal, exponential, gamma, Weibull, and Campbell. We use MLE to estimate the parameter. By using 2 evaluation techniques, the Kolmogorov-Smirnov test and the Akiki information criterion, start with Kolmogorov-Smirnov test. In our analysis, we use ARC software to compute the test statistic and corresponding p-value. According to KS test, a distribution is considered a good fit if the p-value is greater than 0.5 and the highest. Among all 5 rainfall stations, we found that the log normal distribution consistent has the highest p-value, making it the best fit based on the KS test. Next, we apply the Akiki information criterion to evaluate each distribution. The AIC is calculated by using the formula given, where L is maximum value of likelihood function and K is a number of parameters estimated. A lower AIC value indicates the better trade-off between goodness of fit and model capacity. Again, across all 5 stations, the log normal distribution shows the lowest AIC value. We get the p-value for KS test and AIC for each distribution. First, we read CSV file for 5 stations and start with Allostar. Then, we insert the estimate parameter using MLE and calculate the log likelihood function. Next, we compute AIC using the formula, which is -2 times log likelihood function plus 2 times the number of parameters. We display all AIC value and choose the best one with the lowest AIC. Then, we run the KS test to get the p-value and pick the best distribution with the highest p-value. Finally, we show all results in the table. Then, we repeat the same step for the next station.
Kota Baru is a part of the descriptive statistic. Firstly, rainfall is skewed. The data is not evenly spread. It is skewed to the right, meaning most days are dry, but there are some extreme rain events. Secondly, most rainy days have light rain because a large number of rainy days have low to moderate rainfall, especially between 1 until 20 mm. Thirdly, fewer days with heavy rain. As rainfall increases, the number of days decreases, meaning heavy rainfall is rare. Second, the graph shows monthly average rainfall in Kota Baru. The line shows average monthly rainfall, while the shaded region shows the range of variation, meaning how much the rainfall differs from year to year. Firstly, for the lowest rainfall, it happens in February and May with averages below 15 mm, while the highest rainfall peaks in November and December, which is above 30 mm. And for the stable period, it is started from March to October. Rainfall is relatively steady between 13 until 20 mm. For height variability, in some months like November, the shaded area is wide. This means rainfall can be vary a lot from year to year.
To conclude, This study found that the log normal distribution was the most suitable model for the daily rainfall data across 5 stations. So this was based on the highest p-values from the KS test and the lowest AIC values, which indicate the best fit. So log normal distribution accurately represent the squeakiness and extreme rainfall pattern in Malaysia. This result can support better planning for the flood risk, agriculture, and climate adaptation. So thank you so much for your attention.